let's look at permutations using the digits 0, 1, 2, 3, 4, 5, 6, 7. All in all, there are 8 digits. Well, how many different numbers can be formed using a 3-digit number at most once each? Okay, what does that most mean? That means no more than once. It means that you really can't double it up. You can't use it twice. And another restriction is that the number cannot start with 0. So, if there are no other restrictions, we can start looking at the permutations using the following method. We have 3 positions to fill, but the first position cannot have a 0 digit in it, so there are only 7 positions left. So I can put number 7 in the first box. In the second position, I can use 0, but I only have 6 remaining digits to choose from. So that gives me again 7 digits altogether to choose from. And in the last position, I still can use a 0 if I haven't used it before, and I will have now 5 remaining digits to choose from. And altogether, I will have 6 digits now so that I can place in my third position. And using the product rule, the total number of permutations is 7 multiplied by 7 multiplied by 6, giving me 294 permutations. Now we have a different problem because the number must end in 2, 4 or 6. So we will start with the third position, and we know that we can only put in this third position 3 numbers, 2, 4 or 6. Now we can go back to the first position and fill that in. We've already used one digit, one of the 2, 4 and 6 in the third position, and we know we cannot use 0 in the first position, so what we really have is 6 digits left. And here 0 can be used plus any of the 5 digits. I should say the remaining digits. So therefore 0 plus any of the 5 remaining digits leaves us with 6 digits to choose from. And if we use the product rule, the total number of permutations will be 6 times 6 times 3, which is 108. In this example, the number must end in 0, so we have only one possible way of filling the third number, and that must be 0. So now to fill the first position, we only have 1, 2, 3, 4, 5, 6 and 7. So that gives us 7 numbers. So we can fill it with 7 numbers. And in the second position, we now have 6 digits left. So the total number of permutations is 7 times 6 times 1, which is going to be 42. In this last problem, the number must be even. For the number to be even, it needs to end in 2, 4, 6, but also it could end in 0. If you look at the way that I've written it down, you'll notice that I've got 2, 4, 6, then I have a word or here, which is a very important word because it signifies the addition. And then I also have 0. Now, we've already done this because you have already done this particular problem here, and you have already done this particular problem in the last question. So the number that must end in 2, 4, and 6, we have calculated it to be 108 plus 42, which altogether gives me 150 permutations. This may have looked like a difficult problem, but it wasn't in the end when you looked at it in the way that I set it out. So if you did find this a useful video, then please put a like on it, because that really helps my algorithm. And also please subscribe, and you'll be getting notification when the next videos come up.